All right, so now that we've looked at the basics of linear functions, we're going to go ahead and apply what we learned in the first part of the presentation to some application problems. In this section, we're going to talk about slope as a rate of change. We're also going to be talking about interpreting slope and y-intercept. All right, so when we talk about slope as a rate of change, remember that slope represents the change in the vertical direction over the change in the horizontal direction. We can also label these as the change in the dependent over the change in the independent. We'll go ahead and talk about what we mean by dependent and independent in a few minutes. Now, the main difference between slope as a rate of change and slope is that when we talk about slope as a rate of change, you need to make sure that you always include units. We're going to be talking about this in terms of application problems. And so when we talk application problems, we always want to make sure we include correct units. Okay, so let's go ahead and look at some examples, and we'll see what we've got here. Example A, we have in 2005, new privately owned single-family homes in the United States had a median floor area of 2,227 square feet. By 2009, the median floor area had fallen to 2,135 square feet. We want to know at what rate did the median floor area change. Okay, so the first thing we want is we have 2 points here that we want to go ahead and look at. So the first thing that we have is in 2005, it was 2227. So now when we talk about independent and dependent variables, independent variables, we have no control over that. They change no matter what. So in this example, what is my independent variable? It's the time. Do I have control over the year? No, I don't. I have control over the square footage. So my first point is going to be 2005, 2227. My second point is going to be the 2009 and 2135. Again, my year is going to go first. My square footage will be second. Okay, from there, we have 2 points, so I can go ahead and use my formula for slope. So 2 points, again, remember that we want to label our variables or label our coordinates. We have x1, y1, x2, y2. And if we go ahead and plug into our slope formula, if you don't remember it is y2 minus y1 over x2 minus x1. So if we go ahead and plug in, we get 2135 minus 2,227 divided by 2009 minus 2005. All right, if we go ahead and simplify this, I get negative 92 divided by 4, which is equal to negative 23. Now we do need to interpret this. We want to include correct units, and when we talk about rates, there's generally going to be two components to our units. So how is this changing? This is decreasing, or negative 23 square feet per what? Per year. So notice that we have two things when it comes to our units. Make sure that you identify both of them. All right, let's look at a couple other examples. B, I'll tell you, is not my favorite, and hopefully we don't have any like this on the homework. Okay, so let's go ahead and see what we can do here. We have a plane begins to descend to sea level from 20,000 feet after being airborne for 1 hour and 40 minutes. The entire flight took 2.5 hours. We want to determine the average rate of descent of the plane. Okay, so this one gets a little complicated just because we got hours, we got minutes, and we do want to kind of convert that into just one thing. So if we go ahead and do this, 1 hour 40 minutes, 1 hour is 60 minutes, plus 40 is going to be 100 minutes. This is my first point. What is my independent variable? Well, again, it's time. Time happens no matter what. I have no control over it. But we do have control over the height of the plane. So that is my dependent variable. Now it says that the entire flight took 2.5 hours. So, well, what's my height after 2.5 hours? It is going to be 0. 2.5 hours, what is that in terms of minutes? Well, we get 2 times 60 is 120, plus 30 minutes, that's going to be 150. Okay, so let's go ahead and plug into our slope formula. If we label our points, we have x1, y1, x2, y2. And if we plug in, we get m equals 0 minus 20,000 over 150 minus 100. If we simplify this, we get negative 20,000 over 50. If we go ahead and divide, I'm going to cancel my zeros, and I get negative 400. We need to include our units. So what are our units? Well, it's descending negative 400 feet. Remember, my feet are on top, and my minutes are on the bottom. So this is negative 400 feet per minute. Okay, that takes care of that one. Let's go ahead and look at another one. Okay, example C. We have Rachel walked 360 steps on an elliptical trainer after 3 minutes and reached 1,800 steps 12 minutes later. Assuming a constant rate, find Rachel's rate in steps per hour. Okay, so let's go ahead and try this one. This is another tricky problem. But let's see what we can go ahead and do with this. So it said Rachel walked 360 steps after 3 minutes. Again, my independent variable is my minutes. I don't have control over time. I do have control over how many steps I walk. So we're going to do 3 and 360. My second point is going to be 12 and 1800. So now let's go ahead and plug this into our formula for slope. We get m equals, I'm going to subtract my y coordinates, 1800 minus 360, over, subtract my x coordinates, we get 12 minus 3. If we go ahead and subtract this, we get 1800 minus 360 is 1440 divided by 9. This is going to be 160. Now, is this steps per hour? The answer is no. This is steps per minute. So how many minutes in an hour? There are 60. So we want to multiply 60 times 160. And now we get 9,600 steps per hour. Okay, so that takes care of doing some interpretations of slope as a rate of change. We'll look at this again in the next section when we talk about finding equations. Okay, the next thing we want to talk about is interpreting slope and y-intercept. So remember that slope is a rate. To interpret, you need to include phrases that indicate whether it's increasing or decreasing. Is it a positive slope or a negative slope? When we talk about that in the real world, we want to use phrases like increasing and decreasing. We also want to include correct units. Now, as we saw in the previous slide, remember that there should be two components to your units. How is it changing vertically and how is it changing horizontally? The other thing we're going to interpret is the y-intercept. The y-intercept represents the initial value. So you need to use phrases that indicate it is an initial value and include correct units. If the initial value takes place in a certain year, you need to state that year. We're not going to say the initial value was, we're going to say in such and such year it was this. We'll see an example of this in a few minutes. Okay, so let's go ahead and look at example A. Example A, we have the cost in dollars of 1 month of Andrew's cell phone service is given by C of x equals 0.1x plus 39.95, where x is the number of text messages sent and received. Okay, so we want to know the slope. Our slope is 0.1. So in order to interpret this, the cost, that's my y. Here is, remember that c of x represents a y. So how does the y change? The cost increases, it's a positive, 0.1 per, we have x is the number of text messages. So per text message. So notice here that what do we have? Remember I said you need to state whether it's increasing or decreasing. We know our slope is 0.1. We also need 2 units. So I have my dollars and I have my per text message. This is considered a complete problem. Okay, so now let's talk about the y-intercept. And actually in this case, because we are in function notation, we refer to it as the C-intercept. And I call it the C-intercept because that's my function definition right there. Okay, so my C-intercept is 39.95, so how do we interpret that? The initial cost is $39.95. And that's all you have to say. All right, let's look at example B. The amount in dollars that Chad owes on his school loan is given by S of t equals negative 500t plus 6,000, where t is the number of months after he has graduated. So let's go ahead and interpret. What is our slope? Our slope is negative 500. So how do we interpret this? We say the amount owed is decreasing by $500 per month. So again, note that we have that increasing, decreasing word, and my slope, I have included my 2 units. It is decreasing by dollars per month. Okay, what about my y-intercept? Or in this case, my s-intercept. My s-intercept is 6,000. So how can we interpret this? The original amount of the loan was $6,000. Original, initial, these both mean the same thing. Okay, so that takes care of some of those. Let's go ahead and try a couple more, get some more practice. We're also going to do a couple other things in order to interpret these. Okay, so Let's look at this first example. It says perfect printing uses the function given by P of t equals negative 400t plus 25 to determine the salvage value, P of t, in dollars of a printer t years after it has been put into use. So the first thing we want is, what do the numbers negative 400 and 2500 signify? So our slope is negative 400. We want to interpret it. So the salvage value decreases $400 per year. What about the 2500? This is my P-Intercept. So the initial value of the printer was $2,500. Okay, now for B, it says how long will it take the printer to depreciate completely? What does that mean, depreciate completely? It means that it's worth $0. So that's what we are being asked. When will this thing equal 0? So if we go ahead and plug in 0 for P of t, we get 0 equals negative 400 t plus 2500. If we solve this, the first thing I want to do is subtract 2500 from both sides. And then we're going to divide by negative 400. I get 6.25. So it will take 6.25 years to depreciate completely. The last thing we want to know, what is the domain of P? Now, when we talk about domain, we've talked about domain before, and when we talk about equations in general, remember that linear equations, the domain is always all real numbers. But now we're going to talk about domain in terms of application problems. And when we talk about application problems, we want to know, where are we going to have values that make sense? So for instance, can you have negative years? And the answer is no. Okay, you can't purchase this printer before you purchase this printer. So for instance, negative numbers make no sense. So we're going to start at 0. Remember to use the variable that you are given. We are working with t. Now the other thing we have is can the value of your printer be negative? The answer is no there as well. Once it gets down to 0, it's just worth $0. So that's one of the reasons that we found this value over here. When does it depreciate completely? If we go beyond 6.25, then the printer is actually going to be worth negative dollars, and you can't have something worth negative dollars. So we're going to use that number as part of our domain as well. We get our domain is t is going to be between 0 and 6.25 inclusive, meaning I want my greater than, my less than or equal to symbols. Okay, so that takes care of this example. Let's look at a couple more. So the trade-in value of a boat can be determined using the function given by v of n equals negative 250n plus 5,000. Here, v of n is the trade-in value in dollars, and n is the summers of use. So we want to know, what do the numbers negative 250 and 5,000 represent? So negative 250 is our slope. So what does this mean? This means that the trade-in value decreases $250 per summer. I have my 2 units, and I have my increasing or decreasing word. Okay, what about 5,000? So this is my V-intercept. So what we have is the initial value of the boat was $5,000. Okay, that's our interpret. So now let's go ahead and do some calculations. Example B, we want to know, when will the value of the boat be $2,000? So where does this go in my equation? This is my value. So I want to replace my v of n with 2,000. We're going to replace the entire v of n, and now we want to go ahead and solve. So we're going to subtract 5,000 from both sides. We get negative 3,000 equals negative 250n. And if we divide both sides by negative 250, I get 12 equals n. Let's interpret that. So in 12 summers, the trade-in value will be $2,000. Okay, example C, we want our domain. So again, remember that we can't have negative values for our n. We can't go out on our boat in negative number of summers. That makes absolutely no sense. And the other thing that we can't have is we can't have a negative trade-in value. So we need to know, when is this thing going to be equal to 0? So let's go ahead and solve that. I'm going to set this equal to 0. And solve. So we subtract 5,000 from both sides again. And we divide by negative 250. I get 20 equals n. So that's the other portion of my domain. N is going to be between 0 and 20 inclusive, meaning I do want my or equal to inequalities again. All right, that takes care of this example. Let's look at one more. We have the average price, P of t in dollars, of a Major League Baseball ticket is given by P of t equals 0.89t plus 16.63, where t is the number of years since 2000. So let's first analyze this part of it, since 2000. We don't want, when we talk about things in terms of years, quite often you will see this phrase. Was baseball around when Jesus Christ was born? No. So do we want to start from year 0? No. So we're going to pick a year that makes more sense. And so in this case, we're going with the year 2000. Okay, so we also have our average price in dollars. So let's go ahead and start with our slope. What is our slope? Our slope is 0.89. And we want to interpret this. So let's see here. The average price of a ticket is increasing by 0.89 dollars per year. Okay, so that takes care of our slope. So now let's talk about our P-intercept. Our P-intercept is 16.63. Now in all the other examples, we said this was the initial value. But if you look here, our initial value, is this the actual initial value of a baseball ticket? No, because baseball started way before the year 2000. So instead of using the phrase the initial value, what we're going to do is we're going to bring in this up here. What this tells us is in 2000, the average price of a ticket was $16.63. That's the main difference that you do need to be careful about when we talk about t being the number of years since something, is that we're not going to use initial value or original price or something that says this was the starting value. What we're actually going to do is we need to state in that particular year the price, the cost, the whatever was whatever it is. Okay, that takes care of our application problems for this section. In the next section, we're going to be looking at point-slope form and talking about finding equations using some of the information that we got here. Okay, so let's go ahead, take a break, and I will see you again shortly.